Hello everybody, welcome to this vlog. My name is Satya. In the previous vlog, I discussed about BGP, why BGP is required, and how much important role it plays in ISP to ISP connectivity. When I say ISP to ISP, it is like, for example, Airtel is one ISP and Jio is one ISP. BGP plays an important role in establishing the path and routes between these two ISPs, and it is policy based routing. So more it applies economics to the routes. That means less cost routes will be preferred for delivering the packets. Now I told about eBGP and iBGP. iBGP is a form of IGP protocol. It works in conjunction with or with support of OSPF for ISIS. eBGP, as I told, uses policy-based routing and it establishes the paths or routes between autonomous systems, two different autonomous systems. When it comes to iBGP, there are two forms: iBGP full mesh and Route Reflector. What is iBGP full mesh? iBGP full mesh is a scenario in which each iBGP router will form an adjacency with the other iBGP router. All the routes will be exchanged between these two peers. Let's suppose you have 10 routers. Then each 10 routers will form an adjacency with each other. So it will be a lot of routes. Duplication will be there. More than duplication, I should say all the route entries will be learned by each router with respect to other peers. Why it is not used in ISP or a bigger networks? Scaling is a problem. If I am correct, if 10 routers are used in a network, then each router in those 10 routers will form an adjacency with other 9 routers. So the number of routes learned will be huge. Let's suppose you have 1000 routers. Then each router will have to establish adjacency with other 999 routers. It's a huge route accumulation. So the route database RDB will be huge. So the CPU intensive it will be, and it will take a lot of CPU power and memory. That's why if you are using in a small networks like 10 routers or 20 routers, iBGP full mesh is a foolproof concept. You can use it. But if you are using it in an ISP network where thousands of routers are present, then it's not the good solution. For that, it is another concept is used, which is called as Route Reflector. Now what is Route Reflector? As the name suggests, it reflects the routes. Each iBGP router forms or adds itself as a client to the Route Reflector. Let's suppose we have R1, R2 Route Reflector. R1 and R2 are clients of Route Reflector. So R1 will advertise routes to Route Reflector. Route Reflector will reflect those routes to R2 also. R2 advertises some routes and Route Reflector reflects the route to R1. Now let's suppose there is another router 3 which is not a client of Route Reflector. Then it still reflects the routes if it is R3 is a non-client. It is not a client of the Route Reflector. what it does, it learns some routes and advertises through IGP protocol to Route Reflector. Route Reflector, after learning the routes from the non-client, advertises to its clients, that is R1 and R2. If R1 and R2 advertises routes, sends routes to the Route Reflector, the Route Reflector will advertise the routes to non-clients also. So what I'm trying to say is, client to client route is reflected, client to non-client route is reflected, non-client to client route is reflected, but non-client to non-client route is not reflected. Let's suppose there is another router called as a router 4, which is a non-client, which is not registered to the Route Reflector. Then R3 routes will not be reflected to the R4. So this avoids lot of loops. And with this mechanism, iBGP can be used to scale in the ISPs using the Route Reflector concept. Hope this is clear, friends. So if you have any questions, do comment in the comment section. If you like the video, please like it. Okay, thank you. Bye.